Hi everyone, welcome back. Today we're diving into a super useful algebraic concept, the binomial theorem, and how to expand the binomials quickly and efficiently. Whether you are preparing for exam or just curious about algebra, will make your life easier. So let's get started. So what's a binomial? Binomial is simply an algebraic expression with two terms connected by a plus or minus sign. Let's take an example. X plus y is called a binomial. Why? Because it consists from two terms. X is called a term and y is called a term. And we separated between them by plus sign. Another example, 2x power 2 plus 7. This is called also a binomial. 2x power 2, it's a term, it's one unit. Form this expression. And 7 also it's a term. So these two terms formed a binomial expression. These pop up everywhere, from physics to probability. So understanding them is the key. Now, how do we expand binomials? The most common way that we're gonna use during this lesson, it's FOIL method, which is mean the first, inner, outer, and the last term. Let's take x plus y raised to the second power as an example. So x plus y raised to the second power as an example, and we need to expand these binomials, by the way. So the first step let me explain or give you a small hint about x plus y raised to the second power. We've learned it before, x plus y raised to the second power, which is gonna be x plus y and another x plus y because it's repeated twice because it's raised to the second power. So we're gonna start to multiply or follow the method that I mentioned before. First, we're gonna multiply the first term. So the first term multiply these two terms x and x will be x power 2 or x raised to the second power. Let's go to the inner and the outer. So the inner, which is mean x and y, they are called the inner term. So x multiply y will be x y or yx, they are the same because the multiplication is commutative property. Then we're gonna multiply the outer term, which is mean x and the y, the last one, will be also x and y, and the last term, which is mean y multiply y, will be y power 2. And we need to combine this term, we need to make it more simple, so will be x power 2 plus 2xy plus y to the second power. Okay. Maybe you're asking yourself, what's the point of using binomial theorem? Binomial theorem helps us find the expanding of the expression like a plus b raised to power n quickly and accurately, especially when n is a large number. Instead of multiplying everything out by hand, we're gonna use this theorem to find the result by the easiest way, using combination. It works if you use multiplication to find the result, like the way that we explained before. Let's give you an example to understand why we need to use the theorem of binomials. If I said an example a plus b raised to the third power, you're gonna repeat this 3 times because I mentioned before, this is a exponent. And you're gonna find the result of a plus b multiply a plus b, we find it before, a power 2 plus 2ab plus b power 2 multiply a plus b again. We need to multiply this one more time. Then after that, we're gonna simplify this expression to be a power 3 plus 3a power 2 plus 3ab power 2 plus b power 3. What about if I give you an example, a plus b raised to power 4 or 5 or 6 or 7? This is not the efficient way, it's really tedious way. So we need a fast way. This is a binomial theorem. For large exponent, we use binomial theorem, where a plus b power n equals the summation of n c k NCK, you're gonna find this is a partner in your calculator. This is called a combination, by the way. So a power n minus k multiply b power k. Don't worry about the rule, we can explain it in details, but before that, let me give you a small hint about the different exponent and the result for the coefficient. Okay, I have here we have here many expressions, binomial expression, raised to a different power. You're gonna find raised to power 0, raised to power 1, 2, 3, till 5, as you like, okay? And let's look at the pattern that coefficient follow. The coefficient, which is mean the number in red color. I tend to make it red for a reason, and I'm gonna explain it now, okay? So when it's raised to power 0, the result will be 1. We know that. And when it's raised to power 1, it will be the same, but I write 1a plus 1b. You can write it a plus b, they are the same, but we didn't try the coefficient when b1, okay? And I copy all of the coefficient. And I write it here inside a triangle. By the way, we've studied this triangle before. It's called the Pascal triangle, and we're gonna understand what is the reason for this triangle and why it's really special, okay? Before that, let me give you a small hint. You're gonna find this number of term for each expression determined by this rule, which is going to be n plus 1. n here is the exponent for the term. You're going to find n here equals 0. You're going to find n here equals 1. I'm talking about the exponent here. n here equals 2. n here equals 3, and so on till n equals 5. Okay, n equals 4. What is the important to know the exponent? To know the exponent, I know how many terms I have after I expanding this expression. So you're gonna find when we have one term, the exponent 1 will be 1 plus 1, which is mean 2 term. This is 2 term. After I copy all of the coefficients, which is mean the number in red, we called it the coefficient, okay? After I copy all of them and write inside the triangle, and we've learned this triangle before, it's a Pascal triangle, and as mentioned, we have a chance to understand what is the important for the pattern for these coefficients. You're gonna find it's really special, this triangle. We have this number in the middle, where it comes from. By the way, if I expanded the expression, I can find this number, but inside the Pascal triangle, it's really easy. He said you're gonna add the top for these two numbers. This is the result for the coefficient. Let's discover another pattern. By the way, you're gonna find the start and the end is 1 all time. And let's look at 3. 3, it's 1 plus 2, the same. 4, it's 1 plus 3. What about 6? It's 3 plus 3. 4, it's 3 and 1, and so on. This is the most important. You're gonna find for each level we have inside this triangle. This is when n equals 0, the same. This is the same coefficient. This is when n equals 1. You're gonna find 1 and 1, they will be the coefficient for the term inside this parentheses, okay? Here you're gonna find the coefficient when the expression raised to the second power. Look at the corresponding line. Let me highlight one of them. When x, for example, when n equals 2, okay? We explained it before in details. When n equals 2. So look at the expression when n equals, or raised to power 2, sorry. Okay, you're gonna find the same number, the same coefficient we have inside that Pascal triangle. So let's take a plus b raised to the third power, an example to solve this problem. Okay, so a plus b raised to the third power, and I need to use the pattern of the exponent and the pattern for the coefficient to solve this problem. Okay, so the first, I need to know how many terms I have. Look at the exponents. I have 3 as exponents, so I know that when exponent equal 3, I'm gonna add 1. Anything, we're gonna add 1 in, so n plus 1 will be the number of terms that I have in this expression after I expanded it, okay? So I know that I have 4 terms. By the way, all of the terms contain the same variable. We have AB, so we have AB plus AB plus AB repeated 4 times. But you're gonna ask yourself, we didn't have inside after. By the way, this is the result. The result must be equal to this, okay? This is the answer. But in the first term, we didn't have, because as I mentioned before, a will start with the n power. So will be a power 3. okay, because the power here is 3, and all time decreased by 1, decreased till reach to a power 0. This is why we don't have a in the last term, okay? And if you look at the first term, we mentioned before, b will start with the power 0, which is going to be k equals 0 in this case, so we don't write b power 0. We have b, so it will be b power 0, and each time we're going to add 1 to reach to b, will raise to the same power of the exponent of this expression, by the way, okay? So we don't need to write b power 0 because it's equals 1. So I'm going to cancel it, and plus ab plus ab plus b to the raised to the third power. By the way, as I mentioned, a decreased, so this is going to be 2, and this is going to be 1, so we don't need to write 1. And b all time increased, so this is going to be 1, this is going to be 2, okay? Let's look at the coefficient that we have inside the Pascal triangle. By the way, you can generate the Pascal triangle, so you don't need to this picture, by the way. You can generate it from your mind. The start with 1, and each and the first and the last term start 1, the coefficient will be 1, and the middle will be equal to the sum of the above two numbers. So let's look at when n equals 3. This is when n equals 3. This is the coefficient, so the first one will be 1, the second one will be 3, and the third will be 3, and the last one will be 1, but we didn't write the coefficient when it be 1, okay? This is how can we solve the expand, or how can we expand the expression using the Pascal triangle, the coefficients, and look at the pattern that the exponent follow, okay? But what is the importance of the rule? The importance of the rule, we can use it to expand this expression, by the way, okay? And also it's really important when I'm asking you about the specific term. Let's take an example. When I said a plus b equals raised to power 10, for example, and I need from you to find the fourth term, it's equals how many, the seventh term equals how many. I don't need to expand all of the expression, I need only one term from this expression. Maybe I'll ask you about the coefficient of this term, and I want from you to solve it. Tell me what is the coefficient of the eighth term, okay? Something like that. So let's use the rule to solve this problem. The same example, okay? A plus e raised to the third power. So the rule said n ck, which means n choose k, okay? So let's start with 1. N here will be 3, as I mentioned before. So n c, sorry, I'm gonna cancel n, so it will be 3 c k. As I mentioned, it's the power of k of b. So this is the second term, and as I mentioned before, it's a start with 0 to reach to n power. So it will be 0, and a power n would gonna be 3. The next one, by the way, as I mentioned, b will be b power k. Okay, here equals 0, so I'm gonna cancel it. Okay, this is why I didn't write it. So let's go to the next one. The second one will be 3 c. Each time k will be 1. And the second, this is 3 2, and this is going to be 3 c 3, okay, because n k increased all time, as I mentioned. So a will be power n minus k. A will be n minus k. N equal 3, k equal 1, so 3 minus 1, okay, in this case will be 2. This is why we write 2 here, okay? And each time b increase, so it will be here 1, and here a will be b power 2, and here a equals n minus k. N equal 3, k equal 3, so a will be raised to power 0. So I'm gonna write only b, okay, raised to 3. Let's solve what the mean of 3c0. 3 choose 0, okay, 3 choose 0. You can solve this problem or this term, by the way, in your calculator. You have both equals NCR, they are the same, okay? So n, which is mean a factorial of 3. This is the meaning of factorial 3. I'm gonna explain what the meaning of this. And factorial of 0, okay? And we're gonna say I need the factorial multiply n minus k factorial, okay? I'm gonna explain this expression. I'm gonna remove it now. N here equal 3. 3 minus 0 will be 3, so I need here to write the factorial of 3. And let's write this in your calculator. You're gonna find this is equals 1. This is why the first term will be a power 3. This is gonna be 1. Let's solve the second one we have. Let me remove this and solve the second one. The second one, it is 3 choose 1. 3 choose 1 will be factorial of 3 over 1 factorial, okay, multiply 3 minus 2. 3 minus 2, sorry, 3 minus 1 will be 2. Will be 2 factorial, okay? What the mean of 3 factorial? 3 factorial, which is mean 3 multiply 2 multiply 1 over the factorial of 1, it will be 1 factorial of 2 will be 2 multiply 1. Let's cancel this with this, will be 3. The coefficient of the second one will be 3a power 2 b power 1, okay? And the second one, by the same way, you can solve it. 3, it will be how many? It will be 3 a b power 2 plus, when I write, let's write the last one. I'm gonna solve the last one, okay? The last one we have 3 choose 3 would be factorial 3 or 3 factorial, they are the same. 3 factorial, okay, and factorial of 3 minus 3 will be 0 factorial, so they are the same. I'm gonna cancel this with this, will be 1 also, so there will be b power 3. So let's explain it in a different way with a challenging question, okay? I want from you, look at this example that I have here, and I want from you to find the fifth term, okay? The example said 2x plus 3y raised to power 10, and I have the rule, I write it here to help you to find the results. So the fifth term, let's write the fifth term and let's try to find it, okay? So how can we find the fifth term? This is the first, this is the answer, by the way, this is the second, the third, the fourth, the fifth term. What about, in this case, I write the example and the answer to check your answer, okay? But in the exam, how can I check my answer? I'm gonna tell you now. So let's write the rule first, NCK. N equals 10, let's write it above here to help you, NCK, a power n minus k multiply b power k. So n equals 10, I'm gonna write 10. 10 choose k. K equals how many? I said the fifth term. Focus. K start with 0. So k in this case equals 0. K in this term equals 1, 2, 3, 4. Because it starts with 0. So the first term, k, it was 0 power. So in this case will be 4. So a n minus k, which is going to be 6, and b will be, in this case, b power k, which is going to be b power 4. But you're going to ask me, we don't have a in the example and we don't have b. So a in this case, I mean it's the first term, and I mean by the letter b the second term. So I'm going to write down, or I'm going to write it here. Let's write it here, okay? 10 choose 4. A, this is the first term I mentioned, and this is the second term, which is mean b, okay? So let's replace each one. So it will be 2x raised to power 6 multiply 3y raised to power 4. And let's try to find the answer. It choose 10, it choose 10 choose 4. We explained it before, which is going to be factorial 10 factorial over 4 factorial n minus k, which is mean 10 minus 4. So 10 minus 4 will be 6 factorial. Let's write, let's make it more simple, okay? In this case would be 10. You can solve it without the steps. You can solve it using your calculator, by the way. So it will be 10 multiply 9 multiply 7 multiply 8 multiply 6 5 4 3 2 1. This is the 6 factorial. Okay, so I'm gonna write 6 factorial here over I'm gonna leave the 6 factorial alone, and I'm gonna write 4 multiply 3 multiply 2 multiply 1, so I don't need to write 1, okay? I'm gonna cancel all of these numbers, this with this. And let's simplify this expression, by the way. If I divide here by 3, divide here by 3, this is going to be 3. Divide here, this is 2 multiply 4, which is going to be 8, so I'm going to cancel this with this. 3 multiply 7 would be 21, 21 multiply 10 will be 210. So this is equals 210. You can use your calculator, by the way. So this is equals 210. Let's solve this. It will be 2 power 6 and x power 6. So 2 power 6, let's solve it here. 2 power 6, which is going to be 2 power 3 multiply 2 power 3. 2 power 3 equals 8. 8 multiply 8 equals 64. So I'm going to write 64 and x power 6, okay? And we have 3, so this is going to be 3 power 4 and 6 and y power 4. So I'm going to write y power 4 here, and let's write 3 power 4 equals how many? 3 power 4, which is mean 3 power 2 multiply 3 power 2. 9 multiply 9 equals 81. 81. So let's multiply this 3 number. That's all. I'm gonna use my calculator to solve it by fast way. So I have what? I have 210. So 210 multiply 64 multiply 81. So the result should be equals 1 million. Really? So it's really hard. So let's write the number down. It's 1,088,640, and I'm gonna leave the exponent, sorry, the coefficient. So this is a coefficient. I'm gonna leave the variable down. The variable here is x power 6 and y power 4. And let's compare my answer with the answer above. You're gonna find it's really here y power 4 and x power 6, they are the same. And we have this is the number, they are the same, 1,088,640. Okay, by the same way you can find any term. You can find the first term, the last term, the fifth term,